So now let's discuss from this analysis how we can have answer to the very important questions and how it will help understanding the concept of matching motor with the load. So we have seen that this motor is rated at 48 volt and 3 kilowatt of power. So when we have selected 48 volt and we run the simulation with vehicle load of 200 kg. So it see this is maximum voltage we can supply to the motor and this is maximum speed that vehicle can reach on the direct drive at 63 or 65, more than 65 km per hour. But thing is that efficiency is low. The first thing we observed is efficiency is more than 60% for rated load, that is 3 kilowatt, right? That we have seen. But if we supply the 48 volt which is full, we can apply 60 volt in simulation but not in practical if motor is rated for only 48 volt, right? So we are not going to apply 60 volt in practical to this motor, but we have very good conclusion from this simulation result of efficiency and power. So what we are discussing about is maximum speed is around 60 to 70 km per hour speed. So do we require this speed or not? First thing is that if we require maximum speed of 40 or 50, then we need to use the reduction gear. Second thing is this motor is underrated, right? Only using maximum power output below 2 kilowatt. So what we can do is this motor is, even if we supply the full voltage, is not running at rated output power. That means it is also, we are compromising efficiency. Efficiency is also not more than 60%. That means this motor cannot give the better performance at 200 kg load. So what we need to do? Reduce the load to 150 kg in vehicle model and again run the simulation to derive the characteristic and load the characteristic over here, right? Also change the weight in inertia. Here we have 200 multiplied by its radius square. So this is also we need to change to 150. So if you do so, you will realize you can give the higher output power, higher speed, and for that you require the speed reduction also. If your speed is greater than 80-90 km per hour and you do not require this speed, then you can use the speed reduction gear. So your output mechanical power will be calculated from there and input power from here. So then you will realize in some case you require the speed reduction gear to match the motor characteristic with the load. So motor can be run at its rated power around 3 kilowatt to have the maximum efficiency in utilization. Otherwise this motor can perfectly work with the 200 kg of load without having any issue, right? We have seen that if current is within limit, voltage is within limit, right, and speed is also good, only the performance, that is acceleration, will be limited, which is not required in case of golf cart, and here efficiency will be below 60%. So if it is okay, then we can use this motor with this load. But this is to understand how the simulation and its analysis give us the answer to many questions and help us in selecting the motor with the load, so that before starting any project, why it is important to do the simulation of vehicle with the motor with the passive loading scheme.